Understanding steering gear in ships. We are all familiar with the use of a rudder, which helps in turning a ship as and when required. Rudders are the principal system for the entire motion and control of the ships. But we mustn't forget that the entire rudder action is dependent on another pivotal system called the steering gear. Steering gear integrated with the rudder system defines the complete turning mechanism mandatory for each and every ship irrespective of size, type, and operation. The steering gear system has been an indispensable part of the ship's machinery since the advent of the very early ships, which were operated by hand.
Here we have a simple hull, and I'm just going to attach a normal rudder to the stern. If we keep the rudder amidships, we can watch how the water flows around the hull-rudder combination. It flows evenly, and this means there's no turning force generated, so the hull should move in a straight line. If we now turn the rudder to port, we can see the effect it has on the flow of water. This board-type rudder has now directed the water in a different direction. The water has been directed at an angle away from the boat. The extra water increases the pressure exerted on this side, and decreases the pressure on this side. This pressure difference pushes the stern in this direction, inducing the desired turn to port.
Steering gear is equipment provided on ships to change the direction of the ship during sailing or maneuvering. The steering gear works only when the ship is in motion and does not work when the ship is stationary.
We're up on the navigation bridge, and I'm standing in front of the helm here, which is where we steer the ship. So this is the helm here. It has this faint line here where you can give rudder commands. So right now this is midship. If we turn it over, that would be starboard 10. That would be port 10. The reason it's beeping at us right now is because we're on autopilot, so it's beeping at you to tell you, hey, you need to switch over to hand steering. Otherwise, I'm not going to do anything. So here's the different modes here. We got autopilot 1, autopilot 2, which is what we're currently using, wheel or hand steering, call up, and NFU, which is non-follow-up. So here's autopilot 2. This is the heading that we have set for it to steer. This is what the actual heading is, the gyro heading. So we're steering right now 300.1. A couple other modes we have. The radius. This is correlates to the rate of turn. So if we have a smaller radius in the turning circle, you can see the rate of turn increases. If we're going fast enough, you don't want to have a high rate of turn, otherwise the ship will heel over and move a little bit too aggressively in the turn. So try to keep it around like 5 degrees is pretty good. Here's autopilot 1, which we cover up just to make sure you're not trying to hit the wrong switch here. You see here it'll beep at you as well, unless we switch it over to autopilot 1. We have 2 autopilots just for redundancy in case one fails, and every day we switch the autopilot units just to keep the number of hours on them as even as possible. This right here is a gyro compass. It's an analog version of this reading right here. So we're steering 300.1. This is the non-follow-up tiller. When you move this, it'll move the rudder until you let go, and then it'll stay at whatever you left it at. I'll show you an example of how that works here in a moment. Call up allows us to take control from the bridge wings, both the port style bridge wing and how we view. So when the captain and the pilot are coming in to dock the ship, they can stand out here on the bridge wings and allow the controls here themselves. So when we're in call up mode, it allows the ship to steer using this right here. We can also send the throttle over here in call up mode. We can send the stern thruster and the bow thruster out here as well. And this channel looks identical on the starboard side. Okay, so we're going to steer back to our next waypoint, which is 293. And we'll do that in hand steering to demonstrate how we do steering by hand and with non-follow-up. All right, so let's go to hand steering. And he's on 300, so we'll go to 293.
293.
So he's turning the wheel to port 10 there. Our rudder angle indicator shows what he's doing there. We also get some other information that's useful. Rate of turn, so he's turning at a rate of turn of about 8 degrees a minute to port. And then when he gets closer to 293, he's going to have to apply counter rudder to slow the swing of the ship. So there's the counter rudder. The rate of turn is slowly decreasing to about 0 degrees there. So now he's steady on just about 293 there. All right, now we're going to show non-follow-up. So let's switch to NFU.
NFU, rudders amidships, NFU.
So he's going to move that tiller, left 10.
Left 10.
So he's got to hold that tiller and then release it once he gets it on the angle he wants. Let's go right 10.
Right 10.
Okay, so now that he's got it steady on 293, we can go back on the mic, autopilot 2. And now the autopilot's taking over and steering us on 293. There are 2 steering gears. We have number 1 steering gear and number 2 steering gear. These will alternate every day. Even days we try to run the number 2 pump, and odd days we run the number 1 pump. So you can see today's the 16th, that's an even day. So we have the number 2 pump running. Whenever we're coming in and out of port, we always have the number 1 pump on though, because that's attached to the emergency bus. So if we lost power, the emergency diesel generator would turn on and would still give us power to our steering. So these steering pumps, they're hydraulic pumps that move a steering rack that's connected to the rudder. And we'll go back to the steering gear and look at these 2 pumps and the steering gear system in itself.
There are 2 types of power steering systems, hydraulic and electric/electronic. A hydraulic-electric hybrid system is also possible. A hydraulic power steering, HPS, uses hydraulic pressure supplied by an engine-driven pump to assist the motion of turning the steering wheel.
In order to be able to achieve this, the item that we're going to be focusing on in this video is called a steering gear. In order to understand how the steering gear works, we're going to need to briefly discuss the topic of hydraulics and take a look at some of the steering gear's main components. Now in the past, when you wanted to steer a ship, you could do it mechanically. You would find a muscly sailor, you would stand him next to a big wheel, which is referred to as the helm, and he would turn the helm to port or to starboard in order to change the direction of the vessel. The helm was connected via pulleys and levers to the rudder, and that's what actually caused the vessel to change direction. Fast forward several hundred years, and ships are now so large that it's not possible for a single person, or in fact many people, to manually adjust the position of the rudder using pulleys or levers, etc. So how do we adjust the position of a rudder, accounting for the fact that the rudder may weigh several tons? Well, in engineering, there are 4 main ways used in order to actuate something. When we're talking about actuation, we're referring to movement. If we want to actuate a valve, move it from the open to closed position, or any position in between, then we might do this mechanically, perhaps by using a hand lever or a hand wheel. We may do it pneumatically, using compressed air. We may do it hydraulically, often using some sort of oil, or electrically, using some sort of electromagnet or electric motor. Modern steering gears are predominantly electro-hydraulic. They use an electric motor attached to a positive displacement pump, which pumps hydraulic fluid within a hydraulic system. So let's take a look at that in action. Here we have our steering gear. Beneath the steering gear we have a rudder, and further forward or further to the fore we have a propeller. If I press the play button, we can see the propeller turning. If I zoom out a bit, we can actually see the rudder changing position. The rudder now is coming to port. The rudder now is coming to starboard. The rudder is attached to the steering gear via a rudder stock. You can actually see it here. The rudder stock runs up through the rudder, through the hull of the vessel, and connects to our steering gear, which is this green item here. Connecting to the rudder stock is a tiller. This type of tiller is a forked type tiller because it has a fork shape. Between the forked tiller is a pin and a codpiece. Don't ask me why it's called a codpiece, it just is. The pin connects onto a ram. You can see that there's a ram on the opposite side here, and it's these rams that are used to move the rudder. The rams move in a linear direction, either moving to port, which is towards the left side of the screen, or starboard, which is towards the right side of the screen. Although the rams move linearly, the rudder stock moves in a rotary direction, and it's the tiller that converts this linear motion from the rams to rotary motion at the rudder stock. You can also see the keyhole where the rudder stock attaches to the tiller. Over on this side we can see a rudder angle indicator. The rudder angle indicator here goes from 0 to 45 degrees on both sides, but typically the rudder will only move between 35 to 35 degrees maximum. Once you get past 35 degrees, the rudder is no longer so effective, and it's definitely not as efficient because you get small eddy currents or eddies which create turbulence and reduce the efficiency of the rudder and the turning effect it creates. It's a requirement that the steering gear should have some form of local rudder angle indicator. So fixing this plate onto the tiller is a pretty good way to fulfill this requirement. Attached to the top you'll see we've actually got two bars, these two thin connections. These connect usually to a control box and some sort of position indicating transmitter. And we can transmit this signal back up to the bridge so that they can see the position that the rudder is currently in. So a local rudder angle indication is provided here, and a remote rudder angle indication is provided via a transmitter, which transmits a signal that is received in the wheelhouse, also known as the bridge. Aside from that, on both sides of the steering gear we have an electric motor, one here and one on this side, and we have some directional control valves. Here is the one, and go around to this side, here is another. Encasing the rams are cylinders. There are actually 4 cylinders on this type of steering gear. This is known as a 4-ram type steering gear. It's also possible to get 2-ram type steering gears. Those are the 2-ram type steering gear designs that you're likely to encounter, the 2-ram and 4-ram. And the other type of steering gear design that you may encounter is the rotary vane type steering gear, which we can cover in another video. So let's have a look at the steering gear in operation. You can see that the rams are sliding linearly from the left side of the screen to the right, or the right to the left, depending upon which rams you're looking at. So these rams here are moving off to port, and now they're moving off to starboard. Around this piece here, where we connect to the tiller, will usually be a lot of grease. We have a lot of grease because we don't want a lot of friction between these pieces, because friction generates heat. It's not so much that the pieces are moving very fast, because they're not. It's just that the sheer weight of each of these items and the effect of metal pressing against metal will cause some heat, some rubbing, some friction, some abrasion of these parts if we don't lubricate them. And that's the reason we usually add a lot of grease around this area and around this area here. If we take a look again at the steering gear, this time from the top, we can really see how these rams work together in order to move the tiller and the rudder stock. You can actually see the linkages as well that connect to the control box and the transmitter, and how these move as the rams move back and forth. So we know we've got a pump, we know we've got directional control valves, we've got rams, we've got cylinders, there'll be some valves on there as well, relief valves, a hydraulic oil storage tank, or in this case actually 2 tanks. But how are we moving the rams, and how are we correspondingly moving the rudder? We take a look from this angle, you can see the steering gear moving off to port, or the rudder moving off to port, and now it begins to move off to starboard. We're moving the rudder using hydraulic fluid. Let's have a look now at a hydraulic system, and that will help us to understand exactly how the rudder is being moved. So here we have a diagram of the hydraulic oil system used to control our steering gear. Now this is a very simple diagram. A typical 4-ram steering gear system will have relief valves, isolation valves, check valves, also known as non-return valves, and generally the system is much more complicated. That being said, the principle concerning just how this steering gear works is very simple. We use a hydraulic system to move the rudder because with the hydraulic system we can actually be quite flexible concerning just how we actuate the rudder. Let me just show you what I mean. On the left side of the screen here we've got a motor, we've got a pump, and I won't go through all the parts, but we've got here a directional control valve and a tank. That's where we'll store our hydraulic fluid. Typically, hydraulic fluids are oil-based, but you can also use a glycol-water mixture if you have a very large hydraulic system. Now we have another directional control valve here, which we're not actually going to actuate in this simulation. Then we've got our steering gear, which actually is this entire diagram. But you can see we've got 4 rams, 4 cylinders, the tiller, and the rudder stop. Over on this side, the top left, we've got the same setup again. The reason we have the same setup is because in shipping, whenever you have something that's critical to the ship or to the vessel, you double up on it. In other words, you have what's called N+1, some people say N-1, which means you have 100% redundancy. So if we have an oil leak on any part of the system, let's just imagine for a moment that this particular pipe here, which contains hydraulic fluid, would burst. Then we can isolate this entire system here, that is to say the tank, the pump, the motor, up to the directional control valve, and then we can use the other pump, motor, and tank and directional control valve in order to actuate our rudder. So that's why you double up or install redundancy whenever you have a critical system. And they do this also in power stations as well, and pretty much any other type of industrial plant where you have a critical system. A good example might be cooling pumps in a nuclear power station. But let's stay focused on steering gears for a moment. In this example, what we want to do is distribute hydraulic oil to these cylinders, and this hydraulic oil is then going to force the rams to move in a certain direction. Let's have a look at exactly how that will occur. I'll press the play button. Now keep your eye on these directional control valves. Notice now that the valves moved, and these red lines that have suddenly appeared represent hydraulic oil. You can see that the oil is being delivered to the cylinders. As the oil is pumped into these cylinders, the rams are going to move away from where the oil is arriving into the cylinders, and they're going to force oil out at the opposite ends. Let's just back that up again. So our hydraulic oil is pumped into the cylinders, top left and lower right. Usually these cylinders will be called A, B, C, D, or 1, 2, 3, 4, and the rams begin to move. As they move, hydraulic oil is discharged from the opposite ends. What's important to realise here is that hydraulic oil actually occupies all of these lines, so all of these channels, all of these pipes here, as well as the spaces within the cylinders, and we'll also have hydraulic oil in the tanks. So although in our diagram we're actually showing hydraulic oil being pumped around the system, the whole system is already charged with hydraulic oil. If there's any air in the system begins to act quite erratically, and for that reason we bleed off air within the system. Bleeding just means venting off the air. There will be air cocks or air purges, which are normally just some type of ball valve for this reason. When the system is in the condition shown here, we're actually just recirculating the fluid from the suction side of the pump to the discharge side. You can see that the fluid would come up here, go to the right, go to the pump, that's the suction side, and then it would be discharged here, pass through the directional control valve, and go back to the tank. Now there are different designs concerning how the fluid is delivered back to the pump, if it's delivered back directly or via a tank, but the operating principle is simply that we are recirculating hydraulic oil. So we're not discharging any hydraulic oil to our cylinders, which means the rams are not being actuated, they're not moving. So if we go back to our animation, I'll press the play button again. We're recirculating the hydraulic oil at the moment. The directional control valves have changed position again. We're discharging hydraulic oil, this time to the upper right cylinder and to the lower left. You can see the arrows there. And that means that as the rams move, they're going to discharge oil from the upper left and the lower right cylinders. You can see that occurring here. And now our directional control valves have moved back to the recirculation position, and the fluid is being recirculated. So once again, fluid being discharged here into the upper left cylinder and the lower right cylinder, which means the opposing cylinders are having their hydraulic oil discharged. And if we change the position of our directional control valves again, as you can see over here, then we are changing the flow paths within the system, which means the opposite effect is occurring compared to, as we just saw, hydraulic oil is entering the cylinder in the top right and the lower left, and is being discharged from the cylinders in the top left and lower right. This diagram is very, very basic. We are not showing the servo pump. We're not showing the relief valves. We're not showing the check valves. But in order to understand exactly how our steering gear works, you don't need all of that stuff at this time. What we're trying to understand is simply that we can use hydraulic fluid to change the position of the rudder, and that by using a directional control valve, like this one here, we can change the flow path of the hydraulic oil within the system, which in turn allows us to change the direction in which we move the rudder, whether it be from port to starboard or starboard to port. Let's just have a look at that again briefly, because it's a very important part of just how a steering gear works. So here you can see we're recirculating our hydraulic oil. Here you can see that we're crossing over our systems because we want to send hydraulic oil along these paths, and that's where we're discharging hydraulic oil. You can see our hydraulic oil is coming back to the pump. That's represented by the green line, and we can see our hydraulic oil is being discharged from the pump. That's represented by these red lines. Now if we want the rudder to move in the opposite direction, we move this valve. You can see now that where we originally had green fluid that was being returned to our tank or to our pump, now we have red fluid because we're using these lines as discharge lines to the rams and to the cylinders. Let's back it up. Here you go, the green lines, fluid returning, going to the tank, change the position, those green lines become red. So these directional control valves are very, very important because those are what allow us to reverse the direction that we're moving the rudder in. What's also interesting is that we have these two separate systems, two pumps, two motors, two directional control valves, there would also be two relief valves, etc. And if we were to isolate these two systems, we can do that using this valve here, then we can have two separate systems operating completely independently of one another. That again is a safety feature associated with the steering gear. So if we look at the top system, imagine we have an oil leak, imagine the pump fails, imagine the motor fails, imagine that the hydraulic oil tank has a leak. If any of that occurs, then we can completely isolate the top system and we can use the bottom system instead. Depending upon where the failures occurred, we could actually potentially use one pump here to operate all of the rams, or we completely isolate the top two rams and the top two cylinders, and we actuate the rudder using only the bottom two rams and the bottom two cylinders. So completely independent systems, full redundancy, and that's what makes the system so safe. Let's now go back to our original 3D model of the steering gear so that we can have a look at how this whole system works in the real world and how you're actually going to see it if you're on board a ship.
Steering gear system in ship. The efficiency of the performance of steering gear depends on some main aspects. These basic requirements to be invariably met by all steering gears are guided by rules set by classification societies. They can be briefly outlined as per standard requirements, the steering gear should be capable of steering the ship from 35 degrees port to 35 degrees starboard and vice versa, with the vessel flying forwards at a steady head-on speed for maximum continuous rated shaft RPM. And summer load waterline within a time frame of a maximum of 28 seconds. With one of the power units inoperative, the rudder shall be capable of turning 15 degrees port to 15 degrees starboard, and vice versa, within a time frame of 1 minute, with the vessel moving at half its rated maximum speed of 7 knots, whichever is greater, at summer load line. The major power units and the control systems are to be duplicated so that if one of them fails, the other can easily substitute for them as standby. Emergency power supply. The steering gear system is to be provided with an additional power unit, hydraulic pump, etc., connected to the emergency power supply from the emergency generator, which shall be capable of turning the rudder from 15 degrees from one side to another side within 60 seconds, with the vessel moving at a maximum service speed or 7 knots, whichever is greater. Types of steering gears on ships. As ships continued to grow in size and became faster, modern systems easing human effort were incorporated. Basically, there are two types of commonly used steering gear systems present: hydraulic, electro-hydraulic type. Though the system has undergone some major evolution, the basic physics of operation remains the same. The main control of the steering operations is given from the helm of any ship, similar to an automobile where the entire control of the vehicle's steerability rests on the steering wheel of the driver. The control force for turning is triggered off from the wheel at the helm, which reaches the steering gear system. The steering gear system generates a torsional force at a certain scale, which is then, in turn, is transmitted to the rudder stock that turns the rudder. The intermediate steering systems of a modern-day ship can be multifarious, with each small component having its own unique function. We omit to discuss each and every such component in detail. A better illustration of the exact work sequence in a simple rudder system. The rudder system consists of the following: rudder actuators, power units, other auxiliary equipment needed to turn the rudder by applying torque, hydraulic pumps and valves. In hydraulic and electro-hydraulic systems, hydraulic pressure is developed by hydraulic pumps, which are mainly driven by electric motors. Electro-hydraulic systems, or sometimes through purely mechanical means, hydraulic systems. However, mainly advanced electro-hydraulic systems are predominant in ships nowadays. These hydraulic pumps play a crucial role in generating the required pressure to create motions in the steering gear, which can trigger the necessary rotary moments in the rudder system. These pumps are basically of two major types: radial piston type, heel shaft; axial piston type, swash plate. Actuators mediate the coordination between the generated hydraulic pressure from pumps, driven electrically, of course, and the rudder stock by converting it into a mechanical force, creating a turning moment for the rudder. Actuators are now mainly electrically driven by power units. These actuators, in turn, can be of two types: piston or cylindrical arrangement, vane-type rotor. The types of actuator systems depict the types of steering gears present on ships, which are also segregated as ram-type and rotary vane-type arrangements accordingly. Ram-type steering gear system. Ram-type steering gear is one of the commonly used steering gear construction and is quite expensive in construction. The basic principle is same as that of a hydraulically driven motor engine or lift. There are 4 hydraulic cylinders attached to the 2 arms of the actuator disc, on both sides. These cylinders are directly coupled to electrically driven hydraulic pumps, which generate hydraulic pressure through pipes. The ram-type steering gear arrangement produces a considerably high value of torque for a given applied power. The hydraulic oil pressure varies from 100 bars to 175 bars depending on the size of the rudder and torque required. Rotary vane steering gear. In rotary vane steering gear, there is a fixed housing in which 2 vanes rotate. The housing along with the vanes form 4 chambers. The physics behind its operation is similar to the ram type with a small difference. A rotary vane type arrangement is used when the pressure requirement is 60 to 100 bar for producing the required torque. This is the main advantage of rotary vane type steering gear, requiring lesser hydraulic pressure and thus power for producing the same amount of torque as ram type. Procedure of testing steering gears. Safety of the ship is the prime concern for seafarers on board and for governing authorities like IMO. There have been many ship accidents in the past, which includes collision, grounding, stranding, etc. due to failure of one critical system, the steering gear. Hence, crew must be careful in maintaining and testing all the aspects of steering gear present on board. Specifications and guidelines are laid down by the authorities and in the Safety Management System or SMS of the ship to continuously monitor the operation and safety system of the steering gear to avoid any accidents due to its failure. The guidelines for tests and drills are provided in Chapter V, Regulation 26 of SALAS 74. Following tests and drills to be carried out within given period of time as stated in Chapter V. Steering gear, testing and drills. Within 12 hours before departure of the ship from port, following systems to be checked and tested: main steering gear and system, auxiliary steering gear and system, the remote control systems of steering gear, the steering position indicator on the navigation bridge, the emergency power supply to one of the steering unit, the rudder angle indicators showing actual position of the rudder, power failure alarms for the remote steering gear control system, power unit failure alarms for the steering gear unit, automatic isolating arrangements and other automatic. Following listed procedure must be included along with the check and tests described above. 1. The full movement of the rudder as per the required capabilities of the steering gear system present on board. 2. A visual inspection of all the linkages and connection in the steering gear. 3. The means of communication between the steering gear room and navigational bridge must always be operational. Other important requirements related to steering gear are: a block diagram displaying the steering system, the changeover procedure from remote to local steering and steering gear power unit indicating the emergency supply unit must be clearly mentioned. This diagram must be pasted in navigation bridge and steering gear compartment. All officers and crew concerned with the operation and maintenance of steering gear system must be familiar with changeover procedure from one to other system. Procedure for starting emergency steering system. An emergency steering system, as the name suggests, is a system which is used during the failure of the main steering system of the ship. What is emergency steering? A ship consists of electromechanical steering gear unit which steers the vessel from one port to other. Normally steering gear unit is 2 or 4 ram electro-hydraulically operated unit with 2 or more hydraulic motor for the ram movement. A situation can occur in which the remote control operation may fail to work and there can be a sudden loss of steering control from the bridge. This can be due to sudden power failure, any electrical fault in the system or the control system which includes faulty telemotor or servo motor which is used for transferring the signal from bridge to the steering unit. To have control the steering of the ship at such emergency situation with manual measure from within the steering gear room, an emergency steering system is used. Procedure for emergency steering operation. The following points should be followed for emergency steering operation. The procedure and diagram for operating emergency steering should be displayed in steering gear room and bridge. Even in emergency situation we cannot turn the massive rudder by hand or any other means, and that's why a hydraulic motor is given a supply from the emergency generator directly through emergency switchboard, SOLAS regulation. It should also be displayed in the steering room. Ensure a clear communication for emergency operation via VHF or ship's telephone system. Normally a switch is given in the power supply panel of steering gear for telemotor. Switch off the supply from the panel. Change the mode of operation by selecting the switch for the motor which is supplied emergency power. There is a safety pin at the manual operation helms wheel so that during normal operation the manual operation always remains in cut-off mode. Remove that pin. A helms wheel is provided which controls the flow of oil to the rams with a rudder angle indicator. Wheel can be turned clockwise or anti-clockwise for going port or starboard or vice versa. If there is a power failure, through sound power telephone receive orders from the bridge for the rudder angle. As soon as you get the orders, turn the wheel and check the rudder angle indicator. A routine check should always be done for proper working of manual emergency system and steering gear system. An emergency steering drill should be carried out every month. Prescribed duration, 3 months, in the steering gear room with proper communication with bridge to train all the ship staff for proper operation of the system so that in emergency situation ship's control can be regained as soon as possible, avoiding collision or grounding.